Welcome students to your favorite channel and more conceptual channel Production Classes as PSC, where logo can talks the physics. Okay, so today we are in IIT Foundation course. There is the ICSE-10 chapter 1 and this is force and the topic is centrifugal force. And this is the last concept students. So carefully you have to take it carefully, and if you are first in that particular class, then you go back to the previous lectures and you can follow playlist for chapter 1 and you can take it orderly. Okay, so what is the topic of this and what are the different key points? So centrifugal force, and you have to know what is centrifugal force, that is the definition of the physical quantity. And is it a real force? Is centrifugal force is a real force? And you can just take as that particular force as centrifugal force and explain the motion, or is it real or fictitious? And then take some example to clear your concepts, and then the expression used for it, that is about centrifugal force. So let's start with what is centrifugal force. So students, make a note with me. First of all, what is centrifugal force? Students, to know about this, what is centrifugal force, you must know what is centripetal force. Centripetal force, actually I explain centripetal. What is about centripetal? It is a center seeking. It is a center seeking force. That is all the forces, that is centrifugal or it may be centripetal, are related with a circular motion. So when a particle moves in a circular path with constant velocity with a specific mass, and this is the radius of the circular path, then a force acting towards the center, and this is called centripetal force. And I explain what about centripetal force. You can take several examples like merry-go-round, and when you turn a particular rotary, or you can tie a stone with a string and can rotate like that. And all that these are when, or you can go through a molecular concept. So when electron revolves around the nucleus, and there is also a centripetal force acting towards the center, so it is a central force. It is a central force. What is central? That acts along the center. So what type of force is central force? It may be tension force. If we tie a stone and rotate in a circular path, then the tension within the string can provide that particular force. When electron revolve down the nucleus, then electrostatic force can provide that particular force. When earth revolve around the sun, then the gravitational force provides that particular centripetal force. So centripetal force is a type of force that can act towards the center, and when a particular object or particular particle moves along a circular path. So centripetal force this is, and today's topic is centrifugal. When students think, when you moves by car, and if you want to rotate a turning or a circular rotary, or rotary, then your tendency, that is the passengers within the bus, passengers within the car has a tendency to go outward, in the outward direction. So what is centrifugal force? A force, the definition is a force acting away from the center. So a force acting away from a center of a circular motion, of a body in circular motion, in circular motion. So force acting away from the center, from the center of a body in circular motion. So force acting away from the center of a body in circular motion. When a body is in circular motion, then a force acting away from the center. So this is along this direction. A force acts or comes into play, that is called centrifugal force. Centrifugal force. And what is the amount of this centrifugal force? What is the magnitude of centrifugal force? So we can say that the centrifugal force is equal in magnitude with a centripetal force. So what is about centripetal force? This is Fc equal to, we know that mv square by r. So here centrifugal is also mv square by r. If we want to calculate this force, then you have to take into account this centripetal force expression as centrifugal expression. Okay. So what is centrifugal force? A force comes into play, a force acting away from the center, and a force acting towards the center is called centripetal, and which is away from the center, this is called centrifugal force. So take an example to make your concept more rigid. And you can see, suppose this is the center of a metallic platform, that is, we know that this is merry-go-round, giant wheel it may be. So merry-go-round is a metallic platform and you standing at the center, okay. So you standing at the center like that and stretching your hand with a ball, and you can holding a ball and stretching your hand like that, okay. So when you rotate, so the ball also rotate along a circular path, When you rotates, then it is also rotates along a circular path. Suppose, students, a man is standing here, a man is standing at that position. So you can explain the facts, and also as well as your friend can explain that particular facts. If you explain, then you can say that my muscles can provide the centripetal force. So a force required to rotate that particular one, and we know that centripetal force is center seeking, or it is a central force. So a central force, that is centripetal force, and this force provide the muscles of our hand. So our muscle can provide the centripetal force, and there is a centrifugal force along this direction, and these two forces are equal in magnitude, so the ball is in static equilibrium. So the ball is in static, but it rotates. The static condition, you see that the ball is static, but it rotates along the circular path. Okay, so this is the explanation of you. But suppose if you want to fall that particular ball, then you can see that the ball moves along this direction, If you are here, then the ball goes along this direction. If you are here, then the ball along this direction. So the ball is moved along this direction, as seen by this. This is your friend. So your friend see that the ball moves along a straight line, and if this is the circular position, if I take this ball as this circular position, so it is a tangent. So the ball moves along tangent, and this is the explanation. The ball moves along tangent, and this is the explanation of your friend. And you can also explain that the ball moves along this direction. So your explanation is it moves away from the center, and your friend's explanation is it moves tangentially. Okay, so this is called centrifugal force, and the explanation is that, and when we explain a circular motion, then this type of force is take into account to understand that particular motion. Okay, so it is not a real force, but centripetal force, we can say that this is a real force, because tension within the string, if you hold a string like that and it can rotate, and if the string is cut, then the string moves away along the radius, and your friend see that it is moves tangentially. So if this is the circular path, so here the tangent is along this direction, here this is the direction, and this is the direction. So your friend see that the ball moves along the tangent, but you can see that the ball moves along the radially outward direction. Okay, so centrifugal is a fictitious force or virtual force. Okay, so last conclusion is, conclusion is centrifugal force is a type of force, that comes into play, that take into account for explaining the motion, for explaining the circular motion. Okay, circular motion. So centrifugal force is a type of force that take into account for explaining the circular motion, and it is not a real force, and it is not a real force. So it is called virtual or fictitious, that is imaginary. Fictitious, that is imaginary. So all the questions are around that particular chapter is, what is centrifugal force, what is the definition of centrifugal force, is the centrifugal force is a real force, and explain with your concepts, with your thoughts. Okay, so I think students, you are, after seeing that particular small lecture, you can able to explain all the concepts of centrifugal force, and we also explain the expression of centrifugal force. What is centrifugal force? Is it a real force or not? And these are the main concepts related with this. And last of all, I take an example, a numerical example, to explain. This is a more vibrant. Okay, so question number 1, or take a question. So question, a body, a numerical one. This is a body of mass small m, that is mass equal to suppose 2 kg. A body of mass 2 kg moves in a circular path of radius 2 meter, what amount of centripetal force is required for this motion. Okay, so a body of mass 2 kg moves in a circular path of radius 2 meter. What amount of centripetal force is required for this motion? So the answer is F centri equal to mv square by r. So there's a missing one, is the velocity. So if there's a not given, the velocity is not given, then you cannot do the numerical. So a body of mass 2 kg is moving in a circular path of radius this one with a velocity 2 meter per second, suppose 2 meter per second. So the mass is 2 kg and the velocity is 2 meters. So 2 to the 4, and the radius is also 2 meter. Yes, 2 meter. So 2 to cancel and 4 Newton. So what is the unit of force? This is Newton. So 4 Newton force, and it may be a string force. So 4 Newton force is required to move the body in a circular path. And this type of questions arises. It is so simple, but if you take into account another example, like if you want to rotate a circular path with a rotary with your bicycles, then you have to take into account the frictional force. The frictional force can provide that particular centripetal force. And many more questions, and I explain this is the last lecture about the concepts, and I think that I take another another lectures for defining, or I think that it may be a numerical one. So all type of numericals, all type of IIT questions, that may be IIT questions, means this is the foundation course for IIT, so you have to think like an IITian. Okay, so this type of questions I explain for the next one. So students, last of all, continue your study and stay with me, and subscribe and share it, okay, with your friends. So thank you, and last of all, continue your study. Okay.